Hello, in this video I'm going to show you one method of transferring a 3D design from SketchUp to a laser cutter. This will involve converting the SketchUp model into a G-code file to send to the laser cutter. Now there are several different ways of running a laser cutter using G-codes. Mine uses G0 commands to move the cutting head without the laser switched on, and G1 commands to move the laser cutting head with the laser on. So there are no separate laser on, laser off commands within the code. Now this isn't a universal method for transferring any 3D design from SketchUp to a laser cutter. You do have to use your imagination to work out how acrylic sheet is going to fulfill the function you want it to. So there's no magic wand to wave at that stage. What I've got here is a 3D design composed of three different components, each of which corresponds to one layer of acrylic in the finished design. So what I've got to do is transform each of those three components corresponding to each layer into a 2D drawing. So I'm editing the component now, and the next stage is pretty tedious. I haven't found a better way around this yet. What I'm doing is holding down the Shift key and manually selecting each line that makes up the top layer of this component. I wasn't going to make you watch the whole of that. That took a minute or so. And now I'm just checking that all of those lines are selected by orbiting the component. The next thing I'm going to do, now I'm happy with that, is go to Edit, Copy, and then create a new SketchUp file. Just delete the default object there. And then I'm going to paste it and move it to the origin. It tends to kind of click to the origin so you can make it exact. I'm just going to save this down. You don't necessarily need to save this stage, but it's probably a good idea. Once that's saved, I'm going to use a plugin to which I will link in the video description, which lets you export to DXF, choosing millimeters and polylines as your options. For some reason it puts untitled on the end of all the file names, so I tend to just delete that. I've written linear bearing top just so that I remember which layer that is. So that's now a DXF file. I'm going to DXF to G-code, which I've modified in certain ways. I'll also go into that later on. Just going to find that file that I just created, the DXF file. The most important thing here is I need to find the outer cut, the sort of square around everything. It's important for the laser to cut that last, because if it cuts it first or midway through, the square can fall out of the main acrylic sheet, and then the inner holes will be misaligned within that. I'm just looking through the layers browser. Each one highlights to show you which shape corresponds to what. Okay, so that's the outer square I found. I'm just moving that to the end of the list to make sure the laser cut that last. And now go to Optimize and Export Shapes and save down your .ngc file. Now in the drawing, the top piece of acrylic is 3mm thick. So I'm going to get a piece of 3mm acrylic from the store and put that in the machine. I found that a useful guide to getting the acrylic in the machine straight is to use either the top or the bottom bar of the support for the axes themselves. That way you know the acrylic is lined up straight relative to the cutting head. Once that's in there, I'm going to move the cutting head into position by hand. The laser will start cutting at the origin in your SketchUp drawing, so you want to line the laser up with the top left corner of where you want the drawing to start. You can do this by firing small test dots with the laser on low power and gradually moving the cutting head until the dot is as close to the top left corner of the acrylic as you can get it. You can see that before firing the laser, I always shut the lid of the machine. I fitted a safety switch to make sure that the lid must be shut before the laser fires. but that switch isn't present on the standard machine, so all the safety precautions are up to you. Here I'm loading the file up into a program I use called Pronterface, because my laser cutter is converted to run on Arduino, which I'll go into in a later video. There's a lot to that. But as I said, this will work on any laser that uses G-code and uses the G0 and G1 commands to control whether the laser's off or on. And I'm afraid that you'll have to find out what your laser cutter runs on. I'm not really sure how you would do that, but I'm sure that manufacturers' information, etc., will tell you exactly what sort of G-code it's using. So as soon as I pressed that print button, the laser started cutting. As you can see, it's moving quite slowly. It's only going 2 millimeters a second with the laser set on relatively low power. I found that doing 3 passes over each cut with the laser moving quite slowly and on low power is the best way to get edges which are perpendicular to the surface of the material. It is possible using a 40-watt laser to go through 3 millimeters of acrylic in one pass, but the edges are usually quite slanted, quite noticeably slanted by up to 5 or 10 degrees, whereas using 3 passes and a lower strength seems to get fairly perpendicular edges. They're not perfect, it's not a professional quality machine, but they're pretty good. I just skipped over a few minutes of cutting there. As I said, this isn't a professional quality machine, and I probably could get this to cut faster if I wanted, but at the moment my priority is quality, and I'll just gradually tune it up as I use it more. So there's the final piece, and I think it's a pretty good copy of what I had in SketchUp. Now, if you were looking closely when I took that part out of the machine, you'd have noticed that a couple of those nut traps weren't cut out fully. That's because I was actually tuning up the machine for this particular thickness of acrylic as I was printing. That's not recommended. I would always do a test piece. But here, now I've found a good setting for the laser strength for that particular thickness of acrylic on this analog dial. I'm just going to make a note of that for later. I'm going to upgrade the firmware in the Arduino soon so that I'll be able to program in the laser strength precisely and vary it during each G-code file. But for now, this will do. I promised about 3 minutes into this video that I'd explain a little about how I modified DXF to G-code Python scripts to work with my laser cutter. I'll include a link to my modified script in the description of the video, but I'm just going to explain a little bit about how I changed it, which might help you in the future if you want to cut different thickness of acrylic or different materials, for example. The 2 parameters in this script that you'll need to change depending on the material you're cutting are the feed rate and the number of passes. The depth coordinates control the number of passes. If you set axis slice depth to -1, axis mill depth will control the number of passes you do directly. So for -3, you'll get 3 passes. These are the tool parameters here. In the original code, the diameter is set to 2 millimeters. I set mine to 1 millimeter, which seems to be a lucky guess at the width of the cut the laser beam leaves behind it. I may need to change that in future, but it seems to work okay for now. I made quite a lot of other changes to the original source code. It's just probably not worth going through for now. The other parameter, apart from the number of passes the laser makes, that you're likely to want to change on a regular basis is the feed rate. This is controlled in my modified version of this script by the pre-shape cut and post-shape cut lines. You see here it says M203, X2, Y2, Z3. X2 and Y2 mean that the maximum feed rates on the X and Y axes are 2 millimeters. So you'd obviously change both to, for instance, X5, Y5 if you wanted the speed to go up to 5 millimeters per second. Anyhow, if you visit the link in the description of this video, you'll be able to download my modified version of DXF to G-code, as well as the plugin which is written in Ruby, which you can use in SketchUp to export a DXF file. I didn't want to go into too much detail on my modifications to DXF to G-code because there's not really much point if all you want to do is use it on a regular basis. All you need to do in the course of normal use is change the feed rate and the number of passes to suit the material you're cutting. There's a lot that I haven't covered around modifying the laser cutter to use an Arduino so that you can send G-code to it in the first place, as well as how to upgrade the basic Chinese laser cutter to be safe and not fill your room with fumes. So please do subscribe to this channel because I'll be gradually building up a collection of videos about laser cutting, CNC machining, rapid prototyping, etc. And thanks for watching. I hope you found this useful.